Hey, Fusion 360 users, as always, if you don't have your own CNC machine, you are in the right place because you can use ours. Today, we're going to look at how to expedite our aluminum box project and make it in just a single step. Welcome to SendItCNC tutorial number 3, EasyBox One and Done. Today we're going to do something a little bit different. This is a variation on the simple CNC box project that we made in the last couple of videos. Today we're going to take an expedient approach to getting that box made quickly in a single step. And we're going to run into some problems along the way and deal with those. We're going to assume that everybody has downloaded and installed the SendItCNC libraries because they are a prerequisite for what we're doing today. There's a quick video showing how, called Installing the SendItCNC libraries. Okay, let's dive into our box project. Back in the design workspace, in the examples folder, the box subfolder, we open the EasyBox design file. This is the same small aluminum box we worked with in the previous 2 video tutorials. It's designed to be easy to CNC, and we'll make a few changes to make it even easier. We'll make it out of a piece of 3/4 inch thick by 2 inch aluminum bar, cut to a length of 3 inches. And since it's designed to be made in a single setup, there will be no stock allowance on the bottom or the sides. So no machining there. That's how we'll be able to make it in one step, one and done. We'll leave a little allowance on the top and ends so that we can cut a nice finish there. With no allowance on the front and back or bottom, the surfaces of the raw aluminum stock will be the final surfaces of the finished product. The dimensions of the resulting box will be 0.735 inches high, so almost 3/4 of an inch, 2 inches from front to back, and 2.97 inches from end to end. We'll also eliminate the chamfers on the bottom of the box as well. The ones on the corners and on the top are fine, so we won't touch them. Let's go to the stock folder, get the model for a piece of rectangular bar stock, and insert into our current design. I'm not going to move it into position currently, but I will move it out of the way since it's overlapping the model. Now, we'll resize the stock using Edit in Place. We'll change the parameters to 3/4 of an inch thick, 2 inches wide, and a length of 3 inches. Now we have a piece of stock that's the right size. At this point, I'm going to break the link to the rectangular bar stock model because we made it a specific size for this project. Now I want to move it into place. Recall that the bottom of the stock will be the bottom of our finished workpiece. So the easy way is just highlight the stock and say Move. Then do a point-to-point move of the bottom center of the piece of material to the bottom center of the model. That's all there is to it. Let's have a look at what the result is. We have a little bit of allowance for finishing the top of the box, and we see the allowance on the ends. If we rotate this around and look along the x-axis, then we see no allowance on the front or back, all as expected. Now we need to get our vise, and it turns out that we have a vise that's particularly appropriate for holding small parts like this and getting good access to them. In the work holding folder, insert the 4.5 inch vise with narrow 2 inch step jaws. You can see that this vise has interesting jaws that have a narrow section for holding things. The jaws hold the part up just above the vise, which is convenient for machining. Let's bring it into position relative to the workpiece. I just selected the center of the bottom edge on the step of the vise jaw. Then I selected the center of the bottom edge on the model, which, by the way, is the same as the center of the bottom edge on the raw piece of aluminum stock. That's because the actual raw extruded surface of the aluminum bar will be the finished surface on the front and back of this box. Now, we're going to close the jaws, activating that joint as we've done before and using the measure function. Then, highlighting the 2 surfaces to bring together. The vise then closes beautifully. As always, when you do this, you have to be sure to hit Enter to include the positioning of that joint in the position that we're going to capture. Capture position operations should be used sparingly. The very best practice here might be to use joints between the vise jaws and the workpiece. We'll break the link to the vise, which we're doing only to speed things up when we export the file later. Let's save our file Back in the examples folder, the box subfolder, under a new name of course, EasyBox One and Done. We're done modeling the setup, so we can go over to the manufacture workspace now. For the first time here, we're going to create our own setup from scratch. Here's how easy that is to do. We just say new setup and then specify a few things. Machine, well, that's easy. It's a SendItCNC small mill for 6061 aluminum. Now, we need to specify the work coordinate system. This is required so that the CNC operations on our model can be associated with the appropriate location in the real CNC machine. With SendItCNC, the work coordinate system comes from the vise. So, we open the model, we open up the 4.5-inch wide vise and its origin. We're going to use the x-axis and the y-axis of the vise, and then, in fact, the origin point of the vise as the WCS origin. It's that simple. Next, we have to select the model that we're trying to machine, and that's an easy one. It's the box. Next, we specify the fixture, which is just our 4.5-inch vise. Easy. Finally, we go over to the Stock tab and select our rectangular bar stock, which is the model for the stock. All very straightforward. By the way, that was all provided for us in the previous examples where we started with a file called vise, stock, and CAM setups. Next, let's take the vise out of visibility and get a closer look. Then we'll add some CAM operations to set up one. Let's start by adding a probing operation. The probe is part of our standard tool library. Now we'll identify the surfaces. We have the rectangular bar stock showing, so if I just highlight the top surface, it will offer to probe all 4 sides of that piece of stock, and that's perfect for us. That'll ensure that the machine knows the location of the aluminum stock that we're machining, and if the aluminum stock was not quite centered in the vise, it'll correct for that. And if the stock is a little larger or smaller than the nominal dimension of 2 inches wide, it'll account for that as well. Next, we create a 3D adaptive operation to rough out the part. We'll use our trusty go-to 1/2-inch corner radius end mill, tool number 91. You have to make sure that we say this is from setup stock, not previous operation, because in this case, there is no previous cutting operation. If you like, at this point we could simulate, but we don't really need to because Fusion is showing us the in-process stock. Very convenient. You can see that we need to adjust the bottom height down to a little below the model bottom because of the corner radius on the cutter. The corner radius on the cutter is 0.03 inches, 30 thousandths of an inch. So I'll move the bottom height down 50 thou, and then we'll be well onto the straight vertical part of the cutter. By the way, model bottom and stock bottom will be the same. Now, the in-process stock shows things looking pretty good. Next, we can face the top of the model. I'll select the 2.5-inch face mill, tool number 21. And we'll finish the 2 ends and the slight chamfers at the corners. Choose a 2D contour operation and get our go-to tool number 91 out of the tool library. Select just the contours that we're going to be able to machine. Of course, we can't go all the way around the outside, or we'll machine our vise jaws, which will be diagnosed as a collision. We'll extend the tool path by 1/10 of an inch on both ends, just in case the stock is a little oversized. And remember to extend the bottom height 50 thou below the selected contour because of that cutter radius. Now let's do a chamfer on the top. Let's use a predefined CAM template for that. We can say create from template and navigate to 2D chamfer. The template has the chamfer tool pre-selected, so we just have to select the chamfer contours. If you recall, we finished the inside of the box in the previous videos using tool number 93 and a horizontal tool path confined to the cavity. And we'll do exactly the same thing here. Let's simulate this. And things have gone wrong. As you can see, we have a couple of collisions indicated by the small red lines in the progress bar at the bottom of the screen. Those are forbidden in the SendItCNC world. Let's have a look at what's going on with that collision. Click Stop on Collision, then fast forward. You can see that for some reason the adaptive toolpath is trying to machine the vise jaw. That's a no-no for sure, but here's an easy way to address that situation when an adaptive or other 3D toolpath has a collision with a fixture. Just go over to the Geometry tab of the operation and add the appropriate part of that fixture to the model. Of course, 3D Adaptive tries not to cut into the model, so that should correct our problem. So we'll go over to the vise and look at the jaws. And we see that there are a couple of bodies, the jaw truck and the jaw. We're just going to add the jaw to the model and the same for the movable jaw. We'll regenerate the adaptive toolpath, but another error has occurred. A holder collision was detected. If you want to find out precisely what's going on, you could disable use shaft and holder and resimulate and see what the collision looks like. And what we'd see is that for some reason, the tool is going way down below the workpiece. Why is it doing that? Well, as is usually the case, Fusion is doing exactly what we asked it to. It's doing that because the jaw is now part of the model. So we just have to be a little more careful in the definition of bottom height. Instead of model bottom, it really only needs to be stock bottom. Since we added the jaw to the model bottom now extends well below the stock bottom. Now we can simulate this and it will come out quite beautifully. And you can submit this to SendItCNC and get that little CNCer's box back in only one setup. So today we took an alternative expedient approach that was optimized for manufacturability. Along the way, we made our own setup from scratch. This is all about just adding CAM to your design, then getting it made fast. Watch for our live stream where we do the EasyBox One Done project in real time and answer your questions live. In the next video, we're going to see how easy it is to make threaded holes in aluminum on a cloud CNC machine. SendItCNC is the democratization of manufacturing. Check out our other videos.